If we look at human biomonitoring, the key to progress and to significant results is twofold. A constantly enlarged toolbox for HBM on the one hand, and on the other hand, making this toolbox, these new methods, available worldwide. How do you do that? A simple question that requires a sophisticated answer. Please welcome our next speaker. Since 2002, she is heading the Institute of Biomonitoring, Department of Occupational Health at Currenta, a former Bayer company. She's a member of the steering committee of the German Association for Occupational and Environmental Medicine, and she also shares her knowledge as a counselor of the German Ministry of Labor and Social Affairs and the German Ministry for the Environment. Professor Dr. Gabriele Leng.
Yes, hello, ladies and gentlemen here and in virtuality. I would like to give you a talk about difficulties and approaches to enlarge the toolbox for HBM. We learned in this morning there are so many chemicals around, and the question is, for which do you have a method, for which you won't have a method? In general, if there is no method available, you use mathematical modeling to predict the internal burden of a person. This is combined with a high uncertainty of results. So the gold standard for exposure assessment will always be HBM. And this is not only for terms of accuracy, but of costs as well. Yes, the problem is what methods are available. Everybody knows we have methods for lead or mercury or some solvents. Sure, we have them now for plenty of years. So it is a so-called limited toolbox which is available throughout the world. It is traditionally focused on the substances you can see here, heavy metals, organochlorine, pesticides, dioxins, phthalates, perfluorinated chemicals, just to mention a few of them. But even if I would mention all of them, it's only a very part. So what about the many others or modern chemicals? This is why 10 years ago, the German Human Biomonitoring Corporation was initiated. It is a cooperation between two partners, the government and the chemical industry. This cooperation has one common goal, but separate, very separate, transparent responsibilities. The common goal is to enlarge the toolbox, meaning to find 550 very new chemicals for which a method should be developed. And it is supposed to be a method which is so sensible that you can find background level, meaning the levels in population without any occupational exposure. This is our goal. The separate responsibilities are very clearly separated. Government is responsible for the administration and managing of the cooperation, and later on, applying the new methods. Industry is responsible for implementation of the method development. This means they have to find an analytical labs with wide experience and emphasis on biomonitoring. Not every analytical lab can do these method development. There are only a very few of them in Germany, and probably throughout the world it's not very different. Then you need an expert, a toxicological expert, knowing more about the substance in question to go with the project. Beside or in addition to our cooperation, of course, it is very important not only to develop the method, you need two more things. You don't want to measure later on, you want to evaluate. The topic of evaluation will be the topic this afternoon. I just want to say we started here with evaluation purposes with HBM and reference values for the new substances. So when the methods are applied, we can evaluate the exposure simultaneously. So what was the selection process? We had 3 criteria for selection. This is the consumer relevance, health relevance, and of course, the fact that no method is present. Formally, we had 2 panels. We had the expert panel existing from experts from research, industry, and government. They propose a list of substances which meet these criteria and for which method development seems promising, and they monitor and advise the method development until finalization. The second committee is the steering committee from government and industry representatives. They are responsible for the final selection each year of the substances. I don't want to show you all of the 50 substances now, but I just want to give you an overview. We focus on the field of cosmetics, plasticizers, fragrances, biocides, UV filter for plastics, flame retardants, antioxidants, foam ingredients, solvents, vulcanization, fuel additives, insecticides, intermediates, and so on. It's a long, long list, and it is not really easy. It turned out in all these years, what is relevant, what is health relevant, what is consumer relevant. It's not that easy to decide. But these are the substances which we worked on. Another challenge is the choice of a specific biomarker. First of all, you need the substance. But then you have to know, you have to develop an analytical method, and the method is not only the substance itself, no, because most substances are metabolized in our body. There, the problem is that for chemicals, the toxicological information is not that good for humans, not that good as, for instance, for pharmaceuticals. For pharmaceuticals, it has to be existing. For chemicals, no. So what we had to do, we had to postulate. We had to postulate biomarkers from knowledge from animal studies, or metabolism of other chemicals with similar structure. But it turned out that the gold standard is not this kind of postulation, but we had to apply human metabolism study to find out human biomarkers. This process, it's not only time-consuming and costly, but a very big problem is you have to convince an ethical committee that metabolism studies for chemicals are really useful and needed and not dangerous. Then you have substances which are, for instance, carcinogenic, mutagenic. Of course, if you have such a substance, it's not ethical, it's not allowed to do any metabolism study. For these substances, you have the animal and then stop. Nothing else. Technically, for substances with long half-lives, it is not easy. It is possible, but it's not easy to perform a human kinetic study. And then you have the challenge if you have complex substances. But it is very important to have the right biomarker. Here I show you what happens when you choose the wrong one. For instance, if the metabolite turned out to be a metabolite of several substances, not only for the one in question, no, but for many, you have a problem when you look in service later on, because then you can't conclude on the source of exposure. You find something, but you don't know the source. This is not the way we want to work. Then the problem is the substance is physiologically formed in your body. A lot of substances are formed, are produced normally, but if the metabolite in question, the substance in question metabolites to one of these metabolites as well, it is not useful to choose such a metabolite, because then you cannot distinguish between internal body dose, physiological, and external supply. It's not worthwhile. And the third problem is if you have a substance ubiquitously present in the environment, then you have the possibility of exogenous contamination of the human sample. Well, these are the challenges with the biomarker. Of course, you have a challenge. Of course, you have a challenge then with the analytical stuff. It's not easy to develop a method. It's normally, because we are talking about organic stuff, LC-MS-MS or GC-MS-MS chromatographic methods, but the challenge is you need a very low limit of quantification, and you need minimum volume of blood or urine, because it's no way afterwards in the service if I say, well, I need 1 liter of each person. This is nonsense, of course. Urine is better than blood, because when the method is applied for, later on for kids, blood sampling is not that nice. So after developing such a method, we are doing a dry run, meaning that we are applying the method to approximately 40 persons who are not exposed. And then you have 2 findings. The first finding makes you very happy. You find the metabolite. This is great, because it is a good way to say, well, we got it. But what are you doing when you don't find anything? Is it there's no exposure? Or is the method not sensitive enough? Or, the worst thing, do you have the wrong marker? You can only have the wrong marker in case you don't perform the metabolism study, but I told you, for carcinogenic substance, you are not allowed to do a metabolytic study, so of course you can have the wrong marker, and then you can go back to the start, and the whole procedure starts again. So I would like to sum up this study, this project. You can really call a lighthouse project. It is worldwide unique, and it is very successful. It has been a cooperation between government and chemical industry, and we managed successfully to develop 50 analytical methods with high quality and validity, and so enlarge the toolbox for HBM methods a lot with modern chemicals. All methods are published in peer-reviewed journals and can be applied by any lab. This means we are not doing it for ourselves and then that's it. No, everything goes to public, so that every lab in the world having these chromatographic devices can do this as well. We learned that most of all human kinetic studies are really important for method development. We learned that you need to involve the producer of the chemical facilitates the method development. And what we learned, the whole thing is very time consuming. We said 10 years, 50 substances. To be honest, we are not ready yet, so we have 5 more years This is not because we are lazy, but it is because of all these problems combined with this project. You need much, much more time than we already thought. But I mean, this is not, it's just a lesson learned. It's nothing bad. The very good news is that many of the new methods we have developed have already been applied in suitable studies undertaken by the German government, and the results have been and further will be published in peer-reviewed journals. So, to my opinion, human biomonitoring is a key tool of European environment and health policy, and I hope in all these European corporations, the new chemicals will find a way too. Thank you for your attention.